In this video, I want to talk about an important topic which is called superposition. So first, let's just go over the principle of superposition. So the principle of superposition states that whenever a linear system, so that is a very important adjective. So our system needs to be linear, otherwise superposition is not applied. So for all the circuits that we discuss in this course, they are all linear. So whenever a linear system is derived by more than one independent sources of energy, so either voltage sources or current sources, the total response is the sum of the individual responses. So if you have, let's say, a circuit that is derived by 5 different independent voltage sources, so as you can do by now, you can use any of the previously mentioned techniques to come up with the solution for that circuit. The superposition states that if you deactivate the sources all, and then you apply them one by one or one at a time, and then you find these individual responses of the system to that individual source, after you solve that circuit 5 times, you can sum all the results, and then you get the result as if all of them were applied at once. So we will go over an example later on. So superposition is applied in both the analysis of a circuit and also the design of circuits. Another important application for superposition is when you have independent sources in your circuit that are fundamentally different. So for example, if you have both DC or direct current and also AC, alternating current sources. So for example, if you are working to design a transistor circuit that needs to have a DC or direct current system to basically power up everything, and also you want to amplify some sine waves, you can separate between the two and do the analysis for each one of them individually, and then to get the final result, you basically combine the two by using the principle of superposition. So in order to use superposition, we basically deactivate all except one of the independent sources and then solve the circuit. And then we do the same for the rest of the independent sources as well. So at any given time, only one of the sources is activated while the rest are deactivated. The final result is the sum of all of the individual results. As for the circuits with dependent sources, you don't deactivate them. So this only applies to independent sources. So let's just go through an example to see how superposition works. So in this circuit, to the right, we have this independent voltage source, this independent current source, and then we have these 4 resistors, a 6 ohm, a 2 ohm, a 3 ohm, and a 4 ohm. So in this circuit, what we want to do is that we want to find the values for I1, I2, I3, and I4. So first of all, by looking at this circuit, you realize that this is not a complicated circuit to begin with, right? So you can easily solve it by applying the mesh current method. For example, if you consider these 2 meshes and define the currents, or by doing the node voltage method, considering V1 and V2 here, right? And you can easily either calculate the mesh currents or the node voltages, considering both of the sources be present at the same time. But that's not how we want to solve it here. We want to see how the superposition works. So to get to this, we need to deactivate the independent sources one at a time. So at any given time, only one of the independent sources is present. So the first step, what we do is that we go from the initial circuit to the second one, in which we deactivated the independent current source. If you remember from a previous video, we said that for a current source, deactivation means making it zero. For the current source, that is equivalent to open circuit. So for this current source to deactivate it, you have to make the current that goes through this branch zero. And for that to happen, that means that this should be open circuit. So this is what we have now. So since this is open circuit, the current is going to be zero here. So this 2 ohm and this 4 ohm are practically in series with each other. So now that we have this, we can use the node voltage method to find the value for the voltage at this node. So I call this V1 and I write down the KCL for this node. So the KCL is going to be V1 minus 120 over 6. So that is the current that goes to this 6 ohm. Then the current that goes through the 3 ohm. So it is V1 divided by 3. And then finally the current that goes in this branch, which contains this 2 ohm and this 4 ohm. Again, since this is open circuit, there is no current going here. So whatever current goes to the 2 ohm goes to the 4 ohm. So we have V1 divided by 2 plus 4. Since these two are in series, their equivalent resistance is their summation. So this is the KCL for node 1. And based on this, V1 will be calculated at 30 volts. So now that we have the voltage here, we want to find the current that goes through these individual elements. So I named them with a prime accent to show that they are different than the original value that we want to calculate. So what is I1 prime? So the I1 prime is the current that goes from this terminal to this one. So it's going to be 120 minus V1 divided by 6. So 120 minus 30 divided by 6, which is going to be 15 amps. I2 prime is V1 divided by 3. So it is 30 divided by 3. It is going to be 10 amps. And I3 prime and I4 prime are basically the same thing, and that is the current that goes through the combination of 2 and 4 ohms. So we have I3 prime equals I4 prime equals 30 divided by 2 plus 4, or 5 amps. So these are the currents that we get if we only apply this independent voltage source to our circuit and the current source being deactivated. So that, you can say, is the first step in finding the solution to this circuit using superposition principle. So I can rewrite it here again. We have V1 minus 120, the current that goes through the 6 ohm, plus V1 over 3, plus V1 over 2 plus 4. So the first one was V1 minus 120 over 6, which gives us V1 to be 30 volts. And then based on that, we were able to easily calculate the individual currents I1 prime through I4 prime. So now that we have this, it's time to deactivate the voltage source while the current source is in the circuit. So for the voltage source, deactivation means, again, making it 0, which is making it short circuit, because we want its voltage to be 0. So for the voltage to be 0, that means that these 2 points need to be connected to each other, so they are at the same voltage. And that's basically what we did here. So we short circuited this 120 voltage source, but we have the independent current source active. So now we consider this node to be the reference node, and I call this one and this one to be V3 and V4, and for all the individual currents I name them I1 double prime, 2 I4 double prime, and I try to find them. So the way we do it is that I write the KCL for this node. So it's going to be V3 divided by 6 plus V3 divided by 3 plus V3 minus V4 divided by 2, which equals 0. So that is the KCL for this node. I do the same for this node as well. We have V4 minus V3 over 2 plus V4 over 4, and finally for the last one, the current that goes through this branch is basically the current of this independent current source, and since the direction of the current that we have here is basically leaving the node, we use it with positive sign. So these are the two equations that we need to solve in order to get values V3 and V4. So if we do that, if we solve this 2 by 2 linear equation, what we get is V3 to be negative 12 volts and V4 to be negative 24 volts. So now that we have this, we can calculate I1 double prime through I4 double prime. So I1 double prime, the current that goes in this direction, basically enters the node, is going to be negative V3 over 6. So it is negative V3 over 6, which equals negative 12 over 6, or it is 2 amps. So V3 over 6 is the current that leaves the node, goes through 6 ohms. Since the current that we are calculating is in reverse direction, we have this negative sign. So keep that in mind. For I2 double prime, it is going to be V3 over 3 ohm by itself. So we have V3 over 3, or negative 12 over 3, or negative 4 amps. So I2 double prime is negative 4 amps. So that means that the actual I2 is in the bottom to top direction with value 4. So now let's just go through I3 double prime. So I3 double prime is V3 minus V4 over 2. So V3 minus V4 over 2, or negative 12, negative 24 over 2, which is 6 amps. And finally for 4 double prime. It is going to be V4 over 4, which is negative 24 over 4, or negative 6 amps. So these are the 4 individual currents that we have found by using the second case, basically deactivating this independent voltage source while the independent current source is active in the circuit. So again, to recap, we deactivate the voltage source, we keep the current source activated, we write down the node voltage equations based on these two nodes, and then based on this 2 by 2 linear system, we calculate V3 and V4, and based on these voltages V3 and V4, we calculate the individual currents, I1 double prime, I2 double prime, I3 double prime, and finally I4 double prime. So now what is the final stage? Since we only had 2 independent sources, that's all we needed to do individually. So now the next step, or the final step, is to find the branch currents by simply adding the currents from individual responses. So this one is the responses from the first case. This one is the responses from the second case. So we have I1 prime to be 15, I1 double prime to be 2. So the I1 is going to be the sum of these two, 15 plus 2, 17. The I2 prime is 10 amps, I2 double prime is negative 4. So I2 is 10 minus 4, which is 6. And then the same goes for I3 and I4 as well. So as you can see, by using the concept of superposition, we were able to solve this circuit by considering the independent sources one at a time. What I suggest you do is that you verify these calculations by considering the initial circuit without any superposition. Just simply apply the node voltage or mesh current method, whichever you think is easier, to get to these results and verify these results. So in this video, we learned how we can use the principle of superposition to basically break our circuit into multiple analysis. This is especially useful when we want to design circuits that are using completely or independently, completely different voltage or current sources. For example, in amplifiers in which you need to have a DC circuit to power on the circuit, at the same time you want to have an AC circuit for the amplification functionality, superposition is going to be very useful.